Welcome, everyone. I'm Kellye Mantooth. I am an MRI technologist, a certified MRSO and MRSC, and Metrasens National Safety Trainer. We are wrapping up the recognition of MR Safety Week this week, and we have a very special guest with us today. He is a physicist and an elected fellow of the Institute of Physics for his contribution to magnetic sensing. In 2001, he developed the first ferromagnetic detection system for hospitals. He co-founded Metrasens in 2005, which has since become the leading international supplier of ferromagnetic detection systems. His innovations have led to recent international awards from the Institute of Engineering and Technology and the Institute of Physics, as well as the Queen's Award for both enterprise and innovation. And he is currently the Chief Scientific Officer of Metrasens. Dr. Mark Keene, welcome. Thank you for joining me.
Thank you. Hi.
I'm excited to chat with you today for multiple reasons. The biggest one is that this is our day to day. This is what we wake up every day and strive to be better at and see how can we make MRI safer.
Yes, indeed.
So
Yeah.
I want to start with, if you don't mind, I left a sliver of your biography out, and I want to start with how did you get in this space? We know you're a physicist, but how did you get involved in MR safety?
Oh, okay. This is quite by a whole string of coincidences, actually. So, I worked in UK military research very closely with American military research on using magnetics to detect things like submarines and sea mines and landmines, basically hidden pieces of ferromagnetic material. And I was in San Diego at a conference in 2001, and in the evening, after a busy day at the conference, I got back to my hotel room, sat in the easy chair, put the TV on, and the TV happened to come on at that very moment on a news channel, and the news story at that time was the death of a young 6-year-old boy in a New York hospital. Everyone in MRI is familiar with this. This was Michael
Hmm.
Colombini,
Hmm.
and a nurse brought a steel oxygen cylinder into the MRI when Michael was getting into difficulties during his scan, and the massive magnetic field of the MRI magnet tore that cylinder from the nurse's arms, and it hit Michael on the head, and he died of massive hemorrhaging a few days later. But for me, my whole research career as a physicist had been able to detect hidden ferromagnetic objects, and you think
Hmm.
like an oxygen cylinder, a submarine, or even a sea mine. They're also kind of
Yeah.
just long bits of steel, um, completely different size,
Hmm.
but the science all scaled, and
Hmm.
just sitting there in front of the TV, I realized how that accident could be prevented.
Prevented. Yeah.
So I came home from that conference, and um, I spread this story among
Hmm.
my co-workers, two of whom are my fellow co-founders of
Hmm.
Metrasens. So that's really how it all kind of started. It was just this string of coincidences
Hmm.
of being in America at the time, because that news story didn't really make it back to the UK. I'm
Uh-huh.
UK based, by the way,
Uh,
and getting it back to my room at that time, switching the TV on at that
hmm.
time. That news story happened to be the one that was on there at that time, and I think it was an alignment of all of these
Hmm.
coincidences. I think scientists
Hmm.
sometimes call this the butterfly effect, where just things which seem very trivial at the time just kind of end up almost
Uh-huh.
dictating the future. It's quite
Yeah.
remarkable.
So you're in this hotel room and you see this news show and you have this aha moment of, oh my God, we can make a difference in this space. Did you go, did you get on Google at the time and were you like, okay, do ferromagnetic detections exist in MRI? Or, was this one of those things that you were like, maybe I need to do some research into this? Was this just a one-off where this happened, or is this something that we really can add to the space and make it safer? Did you do any research, or were you just like, I can fix this?
Well, I'm always very optimistic, so I came home thinking I can fix this. But the reality is that the idea of detecting things in MRI actually goes back 10 to 15 years earlier than that, where a scientist called Finn was thinking about detecting aneurysm clips prior to putting patients into there. So he wasn't really thinking about MRI safety from the sort
Projectile,
of
yeah.
accidental projectile things.
Hmm.
But no one had worked out really before then how to make it practical, and that was the step that we took. We realized how to make ferromagnetic detection practical, so
Hmm.
that you could actually get a warning if you're inadvertently carrying something into the MRI. In parallel with that, Dr. Simon Goodyear, who is a colleague of mine and is now the co-founder and CEO of Metrasens, he started doing some research into whether these sorts of accidents were common or not.
Hmm.
And in order to, is there a business case to actually
Yeah.
make the effort and to develop products to prevent these sorts of accidents? And what he found was that these things are quite rare.
Hmm.
Serious accidents like that are quite rare. But the other thing that he found was that large accidents such as like gurneys and floor buffers and things going in were like much more common.
Hmm.
And one of the most critical things that Simon discovered was that the the number of times that MR accidents are reported is like pathetically low.
Hmm.
In those days, it was thought that perhaps 3 to 5% of of serious projectile
Actual,
accidents were
yeah.
probably not reported,
Oh
and
my
and it's
goodness.
been wonderful to see since actually that with the people like Frank Sherlock and Manny Canal have really put MRI safety at the forefront of thinking
Hmm.
for
Hmm.
people who operate in MRI. They've done a fantastic job now, and one of the really important contributions that these guys have made is to encourage people to
To report.
report them. So we're getting
Absolutely.
a much better picture now than we ever were. But
Hmm.
back then, with the sketchy information we had, we still felt it was worthwhile to try and make a business
Get
of
something
this.
out there. Yeah. So
Yeah, that's right.
how did you all come up with the name Metrasens? Is there a meaning behind that, or?
Yeah, there are three co-founders, myself, Matthew Willis-Croft, and Simon Goodyear, and we're all still in
Mhm.
the company to this day. And the name came after drinking 2 crates of beer in my backyard, trying to work out what on earth to call the company. And in the end, we kind of came up with the name Metal Tracking Sensors. And
Oh,
metal tracking sensors, but that was a bit long,
yeah.
and so we condensed that to Metrasense, metal tracking sensors, Metrasense, and it was a name that was not already had a domain name or a
Hmm.
trademark associated with it. So yeah, it was decided in the end in a kind of a after quite a bit of beer, it has to be said.
I think that's how every great story starts, right? Okay, so we know how Metrasens got started. We know how the name evolved. Now tell me a little bit about the first product. When you guys finally got something that you're ready to go to market with, what did that look like and what happened?
Okay, yeah. So I actually keep in my office a model of the first products that we actually sold, and let me show them to you here if I can get them the right way up. There's these two little boxes, and they go one either side of the MRI doorway
Mm-hmm.
like this, and
Mm-hmm.
you'll see on this that it is branded by ETS Lindgren, who are a shielded room and especially a shielded room door manufacturer, and we're based in a small town in the UK called Malvern, and we very quickly realised that the place to start selling stuff would be in America really,
Mm-hmm.
because you have the largest number of MRIs per head of capita,
Mm-hmm.
and so we talked to ETS Lindgren, and they said, "Oh yeah, we'll try and sell these for you." And so they're actually branded ETS Lindgren, and so that's what they were. But they were just two little boxes, one either side of the door like that, and
Mm-hmm.
that was what we sold. Oh, and bizarrely, the first one we ever installed was at in a town in the UK called Cardiff. Which is the Cardiff Institute of Brain Research or something, and visited them just like so this was back in I don't know, about 2003 or something, and or maybe 2004, and they still, well, when I actually I visited them just like a couple of years ago, but they still had these up on the wall of their thing, and they were still working as delivered. So they were pretty good products at the time. Yeah.
So how have we evolved our products since then? So tell me the difference in what the first product looked like and maybe where we are now.
Oh, okay. So I don't have a picture with me of our current product, but but they're basically longish pillars that go either side of an MRI door.
Mm-hmm.
And the reason for that extension was to do with being able to basically reject unwanted magnetic fields from other parts of the building. So for example, if you're in a zone 3 control room and I'm on a swivel chair and I'm twisting it, if you do that, the magnetic signals from that can interfere with
Mm-hmm.
with things, and having an extended, people think it's about being able to detect taller, but no, it's not. It's really about it's really just about being able to reject unwanted signals from them. So when we had our first product, we started them installing in an MRI environment. You can't recreate that environment in a lab or a workshop. You have
Mm-hmm.
to put them out into real, because you can't make those sorts of magnetic fields and
Mm-hmm.
so on. And so it the whole evolution of ferromagnetic detection is based upon learning from what actually happens,
Yeah.
and then actually developing the products to work best in that
In that
environment.
environment.
Yeah,
Hmm.
yeah,
Yeah.
and they can't really be developed in any other type of environment.
So the first product that you all installed were just these two boxes, and at what threshold were they installed? Did you put them at the bottom of the door? Were they like waistline? Like where did they go?
Well, they went at waistline because magnetic fields from an object, they spread out quite a long way, so it would
Hmm.
easily detect something at neck level or at foot level. So we wanted something sort of halfway in between, and that's also in the region of the pockets
Yeah. Yeah.
of a person. So that was there, but the modern systems, they actually they're actually physically longer, and that also so they kind of go more or less where
Hmm.
from knees up to ear height,
Yeah.
roughly. Yeah.
And now you and I are talking about our door entry systems, our entry control systems.
Yeah.
So at what point did Metrasens realize, hey, maybe we need something that's just a little bit, or maybe a lot more sensitive, where we can pick up some of these things that are not necessarily projectiles, but they're still a hazard to our patient if they go into the MR environment with them.
Yeah, so that's fascinating. So we call them patient screeners,
Hmm.
and they live normally in zone 2 or 3, but on the in the workflow of the MRI. And the reason that we did that was because whereas patients really have to be either devoid of all metal, or the MRI technologist needs to be aware
Hmm.
of what metals they are
Hmm.
on them. That is a much higher standard of what I call magnetic cleanliness, if you like,
Yeah.
than the technologists have to wear. So in many places, technologists wear Fitbits, wristwatches, all sorts of stuff that you wouldn't really want the patient to be wearing in MRI, but it's kind of okay for the MR technologist to wear. So we realised that it was probably quite important to have a system that could really detect down to very, very small pieces of ferrous metal
Hmm.
on the patients. And they are a single pillar this time, whereas the entry control systems are one each side of the door. I'm just trying to get my hands in view here, one each side of the door. And ambulatory patients can go up to it and rotate, and that
Hmm.
rotating motion is really about bringing all parts of the body close to the sensors, because
Hmm.
the the closer a metal object comes to the sensor, then the the bigger the magnetic field from it, and
Hmm.
therefore the bigger the signal you get. In other words, very, very small objects you might just see on that one part of the turn where they're
Yeah.
closest to the thing, and you might not see at the opposite part of the turn.
And
So
and
yeah,
so
that was.
what year did the screener come along? Was that short, did you realize that shortly after we had the entry control, or was it many years after, or
It was several years after. I think we introduced the screener in about 2010 or 2011, somewhere around
okay.
about then.
Okay.
Yeah.
So tell me the difference then. Let's talk a little bit. We talk a lot at Metrasens about how our devices are passive and how they don't interfere with, like, if you have a pacemaker. So tell me a little bit about why that was important and then how that varies from a traditional metal detector.
Sure. Yeah. Well, let's start with a traditional metal detector.
Hmm.
What metal detectors do is they have a coil, and that coil um, puts out an oscillating magnetic field.
Hmm.
And if there is a metal, because of the physical size of the object and its electrical conductivity, i.e. the ease with which it can conduct electricity, you get electrical currents circulating inside that object, and those currents have another magnetic field, which you then have their own magnetic field then, which you can detect with magnetic sensors or other coils.
Hmm.
What that means is that you transmit a coil that illuminates the object, it
Hmm.
interacts with the object and illuminates it, and then that illumination, if you like, is detected with other coils. A ferromagnetic detector, in contrast, relies on the natural magnetic field that surrounds objects made of steel. So, if you imagine my pencil here was made of steel and not wood, it would have, if you had some special glasses or something which meant you could only see magnetic fields, you
Hmm.
wouldn't see a pencil. Well, you wouldn't see a piece of steel like that. You'd see a um, bigger than a beach ball type
Hmm.
thing, because the magnetic field extends away in a big volume around them. So it relies on that like magnetic bubble or that magnetic field that surrounds the object. And if you approach an MRI machine and you're in the fringe field of the magnet, that bubble actually grows because it actually magnetizes the object. So what happens then is that if that bubble impacts upon a ferromagnetic detection pillar, there are magnetic sensors, or there are sensors in that pillar that try to detect that magnetic field. If they see the magnetic field changing, that's often due to this this kind of beach ball magnetic field passing by it, and so the object doesn't need any illumination to have that magnetic field. Although it is true that the bigger the field it's in, the bigger that will be. But it's all slow. There's nothing oscillating. Now, the important distinction between those two things is that with a metal detector where you're illuminating the object, you're interacting with the object, and that can potentially cause issues with electronic components. And it's always been a big debate in sort of security whether hand-wands can actually damage or interfere with pacemakers in some way or other. And so having a completely passive detector actually means that because you're not transmitting anything, you're not interacting with, say, a pacemaker or a insulin pump or whatever it may be, then there is literally no danger of you causing that device to fail by doing that. And the second thing, part of that answer, sorry if this is a bit long-winded, but
no, go ahead.
This comes down to the ACR safety manual and its predecessors, is that a metal detector, because it measures the conduct, the electrical conductivity of the object, that doesn't distinguish between ferrous and non-ferrous metals.
Right.
So a ferrous metal has conductivity, as does a non-ferrous metal, and they will both be detected by a metal detector. And so you cannot discriminate between the two cases, whereas with a ferromagnetic detector, it's detecting the magnetic properties, not the electrical properties of the object, and therefore ferromagnetic detectors simply do not see non-ferrous metals such as aluminum and copper and things like that. So that distinction is so important because you have to have lots of metal objects going into zone 4,
right?
But they need to be made of either non-magnetic stainless steel or aluminum and these non-ferrous metals to be safe to go in there. If you had a detector that detected them as well, then it just wouldn't work at all. So the ACR makes this distinction that metal detectors are not recommended for MRI, and that's the reason why they do explain that it's because of the because it's a lack of discrimination. And I don't know if I forgot to say, but non-ferrous metals would not get attracted to magnets.
Correct. Yeah. From the static field.
Yeah.
From a static field perspective, they don't pose a risk.
No.
Yeah. All right. So let's talk about where we are right now with our product, kind of what we think the expectation for use is, maybe what some of the limitations for use might be.
Yeah, so I always think let's start with limitations, and this isn't specific to our products. This is specific to the science of ferromagnetic detection. Is that, and at least for entry control, the biggest limitation is this: is that you only detect the presence of ferromagnetic materials. The sensors cannot distinguish between whether that ferromagnetic material is loose and free to fly into a magnet or whether it's tethered. Okay, and this is why so if I went into an MRI as I am now, my watch is probably be okay. I might cause it to misfunction because it's an old analog type, but
Hmm.
things that are actually tied down can be MR conditional,
Hmm.
not least things like MR conditional gurneys and
Hmm.
MR conditional, docking tables, which are obviously MR conditional.
Hmm.
So that is the biggest limitation, is not being able to distinguish what is a hazard because it is a
Hmm.
loose ferromagnetic object
Hmm.
and a non-hazard because even though there's ferromagnetic material in it, then but it's not free to actually become a hazard. So I always reckon that if you took an MR conditional gurney and you distilled
Hmm.
all the steel out of it, you'd probably have enough to make a sizable pair of scissors, for example. That's how much steel is in these things, if not a bit more actually.
Hmm.
And you want a detector that will detect a pair of scissors going in, obviously.
Exactly. Yeah.
So that there are then issues with things like gurneys and other
Hmm.
MR conditional equipment. But at the end of the day, the ferromagnetic detector is doing its job. It is detecting
Hmm.
ferromagnetic material going into an MRI, and that's
Hmm.
the only job it does. It can't tell you whether it's safe to go in or not. So it doesn't take anything away from the MR technologists. You
Yeah.
still have to use judgment. You
Hmm.
still have to use all your training because these
Hmm.
things are only augment things. So
Right.
you can be pretty sure that if a detector doesn't go off when you go through the door, then there's either no ferrous or it's really too small to be bothersome.
Hmm. So I guess that led us perfectly into then like how to use it. And I think part of how to use ferromagnetic detectors is understanding, like you just said, well, when should it go off and when shouldn't it go off? And if we know that we're taking gurneys in there, if we know we're docking the table to the magnet in there, even a conditional wheelchair, all of these things have ferrous components on them, and so we can understand, oh, those will set the FMDs off. And as technologists, if we understand, well, hey, I'm going to wear my watch in the room, or I'm going to wear my dance that have a metal shank in them, or I'm going to wear an underwire bra, we understand that those things will set them off. I think the big difference, at least to me, is understanding when they should not be going off. Like we talked about earlier, walking your patient in. I think this is where it boils down to understanding, your practices, implementing practices that say like, okay, well, I know I set it off. And I think we advocate for ferrous-free technologists, but we're certainly not in the business of dictating what people wear to work, and especially
No.
not what kind of underwear they wear to work. But in this instance, it's implementing processes that say, hey, let's make sure that if we're not going to be ferrous free, do we have anything on us that could become a projectile? And if not, then how do we implement a workflow where we know that we're setting it off and we're not a projectile, but our patient is not going to set it off?
Okay. They all FMDs, you have the ability to set the threshold level, if you like,
Mm-hmm.
which is really the amount of magnetic field above which it will cause an alarm. And all FMDs are adjustable in that way. And so what we recommend for some hospitals is that if they are not going what you call the ferrous free route,
Mm-hmm.
then we would set them on quite low sensitivity with the expectation that the hospital knows and agrees that it will only really trap out potential hazards that are bigger than the things that the technologists carry in.
Mm-hmm.
So in other words, even on minimum sensitivity, our products will, they will capture the floor buffers and the steel cylinders and all these things that could cause a major accident.
Mm-hmm.
Um, but then the smaller things that are kind of in that same span as the underwires or the Dansko things, you have to accept that then for that you
You may
fall
miss
back on
some
training,
things.
and then the hospital will often make a journey
Hmm.
by bringing in measures a little bit at a time, because it is a big leap to go from nowhere to zero magnetic working.
Hmm.
They go on a journey, and then every improvement you make, you can turn up the sensitivity
Hmm.
a little bit more, and so it's helpful to think in terms of journey. And I've seen the most amazing things. So I don't know if I should name hospitals or not, so I'm not. But I have witnessed a pediatric hospital, zone 3, zone 4, where a patient on a gurney with anaesthetists and nurses have gone into an MRI, including, and the patient has an IV associated as well. So a team of about 4 or 5 people and a gurney with a patient on, going from the MRI door closed, open, ingress of the whole lot, MRI door closed, start scanning without the without the Ferrogard system coming off green.
Hmm.
And it is the most amazing thing. So it is achievable
Hmm.
for hospitals who are determined to reach the absolute maximum in ferrous sensitivity. And I also happened to be at that same hospital once when I think it's an anaesthetist had a regular kind of biro or pen took in, and the spring was detected, because not only could they take all that patient and gurney and everything through without causing an alert, those systems were actually set up to the maximum
To be
sensitivity we
sensitive
could
enough to
ever.
pick that up. Yeah.
Yeah, it's amazing. Now, not every hospital can
Operate like that.
achieve that
Hmm.
by a long way, but there is a if you work in a hospital, there's always a journey
To
that
get
you can
there.
go on.
Yeah.
Yeah, and also the I think that each hospital has to find its sort of happy
Hmm.
medium, which is a balance between safety and between the the convenience of the technologists.
Hmm. And when we think about ferromagnetic detection systems, I think one of the things, at least that I think about as a technologist, is it's another tool in your toolbox. So it's not
Yeah,
the know all, end all, be all. It's like, how do we teach you how to use this in conjunction with your current practices to make your environment safer? It would be like me giving you a hammer and saying, hey, go build a house. I mean, maybe you could build a house, but if you've never seen a hammer before, maybe you can't build a house. And then also maybe after I teach you how to use the hammer and then I pull some other tools out of my toolbox, well, then you've got this phenomenal build that you've just put together. And when I think of MR safety, I think of that no differently. There are all of these tools in your toolbox to use, and used in conjunction, you can really improve the MR environment. And I think an FMD is no different than that. It's a tool, and you have to learn how to use that tool. And how does that tool work best for you?
exactly. Yeah, no, that's absolutely spot on, Kelly. And the all FMD manufacturers say what I'm about to say, which is that these are tools for augmenting safety. So it's not like you can buy, if you buy a screener for your patients and the entry control system for your magnet room, you can forget all your other safety procedures because it'll catch them. So nothing is ever guaranteed in life.
Hmm.
Nothing is 100% perfect, and FMDs are not 100% perfect by the way. And the so these systems are really just to go alongside all the training, and we'd really encourage anyone who's involved in MRI to just get as much safety training as possible, because it is just like really important that you don't have accidents, and that you don't cause grief, harm, or damage to
Mm-hmm.
yourself or the
Or
people
your
around you, and
patients.
in
Yeah.
particular your patients. Yeah.
Yeah.
So these are just these are just to assist you.
Mm-hmm.
So, for example, you talk about limitations. The screener product, the patient screening products for ambulatory patients, they almost have no limitations, because they can detect really tiny bits of metal. And I can spend an hour talking through stories of things that have slipped through the paper screening and the interview screening and
Mm-hmm.
things like that. It's just some absolutely fascinating um, stories. Actually, I once did a talk at a MRI safety conference in the UK, and it was only stories. That's the only thing that's the only thing I did. No information, just stories, and it was really good fun. But it's quite remarkable how things can, slip through, and it doesn't matter how
Mm-hmm.
thorough some of these stories. There is absolutely no way that it could have been trapped out. They could have found there were actually physical magnets within a child. There's no
Mm-hmm.
way they could have found those out through the screening process, because the parents didn't know these
Mm-hmm.
had been ingested. And the patient obviously didn't really know, so nothing came up in the history, nothing came up in the interviews, nothing
Mm-hmm.
came up anywhere. And it was not until they were screened with the screener that
That they
it
were like, there's
it
something
yeah that
here.
they actually, there's something here, and it needs looking at. And
Mm-hmm.
yeah, there's been so many saves like that, because sometimes there are holes in the conventional way of
Right.
doing it. So I think that's an example of how an FMD can actually augment them. If
Mm-hmm.
nothing else, it gives an objective test
Mm-hmm.
of whether what you've determined on the screening form and from the patient history, um, whether that whether
Aligns
that
with what they're saying.
yeah,
Yeah.
whether
Yeah.
it's true or not. Yeah,
Yeah.
that's right.
Yeah,
Yeah.
and in the same regard, like we're all human, and I think sometimes people will get something implanted in their body, and it's been 20, 30 years ago, and it's just so easy to forget that that was there.
Yeah, no, well, yeah. Not only that, but you have to appreciate that there is one method a hospital has for screening patients, but there's a whole spectrum of people with perhaps on mental health scales. Some people
Hmm.
might not understand the questions, might not have the
Hmm.
memory.
Hmm.
There's elderly people as well. There's people of different cultures and languages. There
Hmm.
are all sorts of reasons why the screening form is not, and some people just lie, basically. Has it has to be said,
Unfortunately,
and
yeah.
you don't want to be putting your patients on a lie detector when you're interviewing them and going through the form. So yeah, it's absolutely right, and there's a lot of value in that. And yeah, I mean, you may be aware that we've just brought out a new type of patient screener called the Ultra. We just
Hmm.
released a new version of that, which is like even more sensitive than the older one, and also has quite a few new features on it that are an improvement over our original one. So
Well,
we're very
well,
excited about that.
yeah. Well, so since we're talking about new products, can we talk a little bit about where you think the direction of ferromagnetic detectors are headed?
Yeah, not. I That's a difficult one for me, because we obviously we have to keep. I can only answer that in general terms,
Hmm.
because we are a business, and if we don't if we don't keep the future under wraps, we won't have the business of providing these safety things anymore. So, yeah, I think for me, there are obviously issues like for hospitals that don't want to like enforce policies on their technologists, clothing and things like that. We're always thinking about ways to make their lives better.
Mm-hmm.
But for me, the one of the most interesting things is that MRI seems to have gone mad in recent months in terms of we now have interventional, we have interoperative, we have
Mm-hmm.
multimodal, we have
Mm-hmm.
MRIs with Linacs. We have all these mushrooming things,
Mm-hmm.
and they have their own kind of real safety concerns, and
Mm-hmm.
some of these techniques are really becoming more and more commonplace.
Mm-hmm.
And so, just the amount of the number of say interventional MRIs and all the equipment that has to come in and out of
Mm-hmm.
those rooms. Yeah, the future FMDs are going to have to find some way of managing or coping with
Mm-hmm.
with with
With
with,
all
with
these
things
different
like that.
environments.
Yeah,
Yeah.
yeah.
Well,
That's
it's
right.
been interesting, Mark. I'm so excited that we got to talk today and that we got to kind of tell everybody, what we think about FMDs. And like I said, we wake up every day. This is our world and our day to day, and we think, what can we do to add value to this space, and how can we make this space better? And so it's been really nice getting to chat with you and maybe bust some of these myths of, oh, these things don't work, but we know that they really do.
Yeah. Oh, yeah. Yeah. They do their job of detecting ferromagnetic objects. It might That might not be what the expectation is. The expectation is to tell you whether something is safe or not safe.
Hmm.
They all they do is they tell you that something ferromagnetic is going into that room, or something ferromagnetic is on that patient, and they do that very well. It it doesn't know that it's a technologist or
Hmm.
an anaesthetist or something going in. It just tells you that, and so it's the use of that information, which is the skill that MRI technologists have to come to terms with. So I
Hmm.
think it's a difference between expectation and actually the knowledge of what it really does, Kelly. It's a difficult thing to manage expectations, and
Yeah, yeah, for
yeah,
sure. We talk a lot about alarm fatigue, and I think that's part of that. But I think, just like you said, knowing the difference and knowing, okay, this is its job and this is what it's doing. And now this is an instance in where it should not be going off. If a patient's coming
yeah,
in and they should be ferrous free, it should not be going off. And so just being able to explain that to people and say, hey, we know that it should be detecting here and it's doing its job. And we know that it is detecting here and something is going off, but it shouldn't be. So we need to investigate that further. And I think that's the important part that we need to get out there to everybody. We need everyone to understand if it's going off, there is a reason why it's going off. And it's up to you to determine, is this an instance where it's okay if it goes off, like if there's a
mm,
conditional gurney going in, or is this an instance where you're putting a patient on the table and there's someone barreling in with a ferrous oxygen cylinder and it should not be going off? And so I think that's what we wanted to address today and talk about is you need, as a technologist, you have to understand when to expect it to do its job, and then, hey, it is doing its job and it shouldn't be going off, so I need to be alarmed, I need to be worried.
yeah, and many places use quite innovational kind of ways to use
Hmm.
FMDs. Like I know of several hospitals that if they're wheeling a patient in on a docking table or on a MR conditional gurney, and the alarm goes off, they know it's going to go off every time that goes in,
Hmm.
but they use that as a signal to just take a time out, have a final check under the
Yeah,
sheets, have a final
absolutely.
check if there's a cylinder on it, and then proceed, because
Absolutely.
then they've done a
They've done their
final
due
check.
diligence. Yeah,
Yeah,
exactly.
the danger is to say, well, it just goes off every time I go into the
Hmm.
MRI room, and then if one day it's actually got a steel cylinder rather
Hmm.
than an aluminum cylinder on it, then that could lead to accidents. And that's the danger with alarm fatigue,
Hmm.
is that it takes away from the the overall safety level.
Hmm.
So
You
the
always you always have to be vigilant. There's never a day where you can say, "Oh, it always goes off. We just won't pay attention to it." You have to develop practices in your facility that work towards saying, "Hey, we use this in conjunction with these practices to ensure that there's nothing harmful
yeah,
here." Yeah.
yeah. And along, so you need to use the alerts to one's advantage,
Hmm.
rather than allow them to become a source of alarm fatigue and just ignoring the safety. They are a safety system at the end
Hmm.
of the day,
Hmm.
and that's quite is quite an important distinction to make. And if you're not happy, if someone, or if a facility is not happy, then they need to have a conversation, because we can say, well, we could turn these down so that we can avoid alarm fatigue,
Hmm.
and but you have to accept that it'll only then capture the bigger potential hazards or accidents,
Yeah.
and some of the smaller stuff might actually,
Be missed.
watches and
Yeah.
things might actually be missed. Yeah,
Yeah, I agree. Well,
yeah.
Mark, thank you for joining me. It's been a pleasure getting to talk to you about this.
Oh no, thank you for talking to me a bit about this. And I just wanted to say to anyone out there, if you have questions, please contact Metrasens, and we can try and get them answered for you. And I'm personally very happy to field questions and things like that. So please get in touch with us, and
Absolutely.
it'd be great to talk about your concerns,
Mhm.
issues, ideas. Feedback is all very, very welcome.
Mhm.
Thanks.
Okay. Well, we're wrapping up Safety Week 2023 for Metrasens. If you haven't already gone back and watched this week, we've had Jeopardy on Monday. On Tuesday, Toby Gilk and I did MRI Safety, Joint Commission MRI Safety. On Wednesday, Toby and I chatted about recent adverse events. And then yesterday, we talked about where do we go from here? What do we do now? How did we get here? And then, of course, today, Dr. Mark, Keene, and I. So we hope that you guys have enjoyed MR Safety Week. We hope that you'll take a little bit of all of this with you and find a way to implement it, not just during Safety Week, but in your entire career as an MR tech, and keep our patients and our staff safe. Thank you for joining us.
Bye. Thank you.